you're dealing with Radian Measure today. Now, we've done a lot of this, so let's get the learning goals down. Then I'll go through, we'll review the ratio that compares radians and degrees, and then we'll have a worksheet that you picked up on the way in that I'll give you instructions on. Okay, so get those learning goals down to begin with. I'm also going to hand back a bunch of your rational function portfolio pages. There's some corrections. You guys did much better on them, those of you who turned them in. There are many of you that still haven't turned them in. Okay, they're counted as late now. Make sure you get those in. Okay, can I have your attention, please? All right. Hey, much better. Some of us are pushing that 5-second limit, though. Come on, man. So, comparing ratios, or the ratio that compares radians to degrees. What did we use on Friday? Those of you that were here, those of you. How many of you that were gone actually went and watched the video lesson? How many watched the video? Okay. The video, the stuff we did in class, it's a 7-minute long video. It doesn't take that long, and it explains it pretty darn quickly. The other video is just an amazing video to watch, so you should watch it. What's the ratio?
Pi over 80 equals R over D.
360 equals X over 2 pi.
How about the one we used in class was actually pi over 180. Okay, that's the ratio. We actually set that as a proportion equals R over D. Now those of you that
R is A as in arc.
Yeah, R is radians, right?
Yeah.
Radians over degrees. Yeah. Now for those of you that were gone, we actually, the worksheet said 2 pi over 360. Well, 2 pi over 360 reduces to pi over 180. So we changed it to that. Or it may have said 2 pi to degrees as, was it 360 to, was it? Okay, so it was a bit different, but we simplified it to this on Friday. Okay, so pi over 180 is equal to our radians over degrees. All right, so I want you to take the sheet you grabbed on the way in, and this is broken down. This worksheet is, or this warm-up here is broken down into angles of 45. So in angles of 45, you're actually drawing in your angles of 45. You're going to label those angles of 45. For instance, I'll give you the first one right here. And the second one. Okay, so the first one is 0. And the second one is 45 degrees. Okay, so at 0 degrees, you're at how many radians? 0 radians. At 45 degrees, you're at how many radians? Good, pi over 4. Now, some of you have that memorized. Some of you don't, so you have to think, well, a half circle is pi. Okay, and 45 is a quarter of a half circle. So that's pi divided by a quarter, or divided by 4, pi over 4. Okay, so 1/4 pi, a quarter pi. So keep going. Angles of 45 degrees. Get them all on here. And then down below, do the angles of 30 degrees. Fill that out. Do the best you can without using notes or your neighbor. Okay, so hopefully this goes pretty easy. Counting by 45s, 45, 90. What's next? 135.
270, 315, 360.
Okay, so hopefully from there you go pi over 4. That's 1 pi. It's 2 pi over 4. 3 pi over 4. 4 pi over 4. 5 pi over 4. Just counting by 4. 6 pi over 4. 7 pi over 4. And 8 pi over 4. Now, we'd want to simplify those. That one's good. 2 pi over 4 is?
1 pi, 2.
Good, pi over 2. Okay, 3 pi, okay, that's good. This is pi. That's good. This is?
3 pi over 2.
3 pi over 2. Good, and 2 pi. Okay, now how many got those? Okay, how many got those that quickly? All right. So the goal is for us to be able to duplicate this quickly. So if we're going angles of 30 next, And you can draw in your unit circle. It's there for your help. Angles of 30, counting by 30. 0, 30,
60, 90, 160, 180, 210,
Okay. This is 0. Now, angle of 30, we know that 180 is pi. So 30 is 1/6 of 180. So that is pi over 6. This is 2 pi over 6. 3 pi over 6. 4 pi over 6. 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6, and 12 pi over 6. And then reducing, that makes this pi over 3, pi over 2, 2 pi over 3, pi, 4 pi over 3, 3 pi over 2, 5 pi over 3, and 2 pi. All right, so it's easy if we can count by those degrees, or those pi over 3 in our degrees, okay? How many get it? All right, you're going to get a brand new unit circle. I want you to clear off your desks right now. Completely clear them off. I'm going to give you a clean unit circle, and on that clean unit circle, I want you to duplicate all angles and degrees, all angles and radians, and all special angle coordinates. Okay? The coordinates. See if you can remember it. Complete the units. Okay, so here we go. See how we did. Start here, we go 30, 60, 0. Okay, and we count by our, actually before I do my 45s, I'm going to go on to here. So, if we're counting by our radians, this is pi over 6, 2 pi over 6, or pi over 3,
Pi over 2.
3 pi over 6, or pi over 4 pi over 6, or pi over 2 pi over 5 pi over 6, and pi, which we got here. Okay, and so that's 6 pi over 6, 7 pi over 6, 8 pi over 6, or 9 pi over 6, or okay, and 10 pi over 6, or and 11 pi over 6, and 12 pi over 6, or 2 pi. Okay, so we have all of our radian measures for the 30s. So we need to get our 45s in. So 45, 90, 135, 180, 225, 270, 315. Okay, and then we go 0. So this is 0 pi also, or 0 radians. Okay, and pi over 4, 2 pi over 4, or pi over 2, 3 pi over 4, 4 pi over 4, or pi, 5 pi over 4, 6 pi over 4, or 3 pi over 2, and 7 pi over 4. And then 8 pi over 4, 2 pi. Okay, so then we have our, how many of you got all those without making any mistakes? Okay, we've got them all simplified. All right, so then we go to our coordinates. I'm going to put our coordinates right here on the inside. That way they're a little easier to see. But, hey, this is obviously 0, 0. Okay?
Should be
Oh,
1, 0.
1, 0. Hey, does anyone recall what we did to help us start this out? Riley?
We set the radius equal to 1.
Yeah, we set the radius equal to 1, and we said that this was, so we wrote 1 in a different way.
It was screw.
It was,
It was wasn't pi over 4 over, no. Yeah.
Good?
Root 4 over 2.
Good, yeah, we called this root 4 over 2.
I was right, darn.
Okay.
I didn't mean pi, I meant root. but-
So, hey, done talking. What did we call 0? Yeah? Root 0 over 2. Okay, so both were over 2. One starts at root 4 and counts down. The other starts at root 0 and counts up. So if this is root 4, if we're going through, this would be root 3 over 2. This would be root 2 over 2. And root 1 over 2. And root 0 over 2. Okay, in terms of our first coordinate. Now some of you will simplify those as we go. Root 0, this is root 1 over 2. No, you cannot put it in decimal. No. Okay, root 2 over 2. So you're counting up here. Oops, over 2. Root 3 over 2 and root 4 over 2. Okay, simplifying them as we go. This is 0. This is 1. Not so obvious that it's 1. And this root 3 over 2. This is 1/2. Okay, root 2 over 2. Root 2 over 2. Root 1 over 2 is 1 over 2, so 1/2. And this becomes root 4 over 2 and 0. So 0. Root 4 is 2, so 0, 1. Okay, and then we reflect the points. We shouldn't have to count anymore. We should just be able to reflect. This point here is a reflection of this. Y doesn't change. X this becomes negative, so negative 1/2. This is a reflection of this. All of our x's, remember, in this quadrant are negative, positive. Over here, they were positive, positive. Okay, so all of they're the same coordinates. They're just x is now negative. Okay, and then we keep going down here. We have negative, negative. So now everything's negative. So this is negative root 3 over 2, negative 1/2, negative root 2 over 2, negative root 2 over 2. So we're reflecting now downward from here. And so this one is negative 1/2, negative root 3 over 2. And this is, or 0, negative 1. It could be negative 0, which makes it 0. All right. So this is positive, negative, and reflecting over. So we have 1/2, negative root 3 over 2. We have root 2 over 2, negative root 2 over 2, and root 3 over 2, and negative 1/2. All right, and obviously 1, 0. Okay, or 0, 0. All right. How many got it all right? How many can duplicate it tomorrow on your quiz? Okay, study it up tonight. There are patterns involved. Now, we talked about them here, so these will be online. We also talked about them on the previous 2 lessons, so those are online. Any questions?
Will decimals be accepted on the quiz tomorrow?
No decimals on the quiz. Fraction form. Okay. Hey, just real quick, in example 3, it's kind of the only piece that we haven't talked about. Everything else we've done on here. We've talked about exact values of cosine and sine. You use your unit circle as reference. In example 1, you're just converting radians to degrees and degrees to radians. But when you get to example 3 gives you the directions. Here, we'll put them up here. Given the radius r in a gear, given the radius r of a gear and an angle theta of that gear, that the gear turns, find the length of the outer edge of the gear that turns past a given point, round your answer to the nearest tenth. So you're thinking of a gear, and when you're thinking of a gear, you're thinking of it in terms of, let's just call it a circle, okay? So if you have a circle, you're trying to figure out how far a gear turns past a given point. So let's say if we focus in on that circle right here, this is standard position of the unit circle, and you think of the outer edge of the circle, what degree are we measuring in? Let's say if we went this far, what are we calling that angle measure? Okay, so you're kind of going, Zach, if we don't know the angle measure, what variable are you using?
Theta.
We're calling it theta. So the amount our gear turns in terms of degrees is theta, right? What if it went a full circle? How far is that?
360.
360, right? Or in terms of radians, it is
2 pi.
2 pi. Everyone with me? Okay, so 2 pi, if we went a full circle, theta would be to 2 pi as, now let's think of length. They're asking how far it's turned. That's not angle measure now. Now we're talking about length. So when we're talking about length of a portion of a circle, what are we calling that? It's called our arc length. And the total length something can turn in a circle is how far? No, in terms of length now, not degrees. Starts with a C. It's our circumference. And what do we call that? Okay. What's another way of writing circumference? 2 pi r. So if our angle goes 2 pi radians, then our arc would go 2 pi r in terms of length. Is everyone with me? So this is a proportion. Now, we don't have to do this for every problem. We're going to come up with a formula that will help us out here. Okay? Cross multiply. We get 2 pi a. Cross multiply, we get 2 pi r theta. What do both sides have in common? 2 pi. Divide by 2 pi. A is equal to r theta. So if we know r, what does r mean? Radius. Not radians, it's radius, right? 2 pi r. If we know the radius and we know theta, we can multiply the two to find out how far the gear turned. Do we know those things?
Yeah.
Yep, we know those two things.
Oh, see this the most. Please.
Yes? Yes, leave it in terms of pi, please. Very good. Oh, hold on. You know what? Let's round to the nearest tenth like they've asked. Let's multiply that out. Round it out to the nearest tenth. Hey, guys, these are good questions being asked. Do we use the pi button or 3.14? You never use 3.14 ever again. Always use the pi button. Okay?